Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on scientific programming using Python. Now, the last session, we were looking at some important concepts like for loops, if clauses, functions, slicing, and modules in great detail. Okay, and today, and also I told you guys to have a look at these two problems. One first problem is an easy problem to find the Fibonacci numbers. Find the Fibonacci numbers up to 12th term with the little catches in between them. And then a second problem is a little bit harder, but it's not actually that hard. But it's kind of a scientific problem wherein you are requested to calculate, you're actually told to calculate the certain parameters like E, temperature, pressure, density, and so on and so forth using the expressions given over here. Okay, now let's do that today. This is about it, and these are not necessary. These are actually some notes I gave for. I'm conducting this tutorial session. I'm conducting a workshop in my department, and these are some installation important information to them. So it's not necessary. So you can just guys can skip through this. It's not necessary. Even these are just not necessary. Okay. Now this is where we begin with. Now I'll come to this extracting text files and writing data to text files and everything next in some other subsequent tutorials. But as of now, let's solve the problem one. But to solve problem one, okay, what you do is that you just write a simple code and work with that. Okay, let me open this file and show you guys what's happening. Now if I open my folder over here, I already have this exercise print done. So this has the file name is ex1.py. Let me open this up. Okay, now this is the code I have written over here. Okay, now let me guys walk you through the problem. Okay, the problem question is find the first 12 Fibonacci numbers, but calculate them from the 0th Fibonacci number and calculate all the 12 terms like up to F12. Use NumPy arrays and set the data to be int 8, and then check whether something is happening or not, and then look at integer 6 and use int 16 and go about with that. Okay, and now I think for this I need to demonstrate you guys a little bit about numbers and also. Let me just open a program called a Scripta. I have it over here. Let this open up. Anyway, let's come back to our problem over here. Let it open up and keep. Okay, crap, I think it has to wait till this entire thing minimizes. Okay, fine. Now let me walk you guys through. Now okay, now let me go through. Now import this line, import numpy as np, tells the Python code to start open the numpy module. Now this is the entire script. It's not a sample script like this, where this is actually a full-fledged program, a simple full-fledged program. Okay, now import numpy as np, it's telling that the import numpy module as np with the alternate name np, and then I'm getting the value from the user as to how many terms to calculate using the value n. And then the first thing is you need to you can calculate the Fibonacci numbers by just repeated iterations and all, but why I use numpy arrays is that if you want to save these values, you can use numpy arrays and numpy arrays. Okay, that's the reason. Nothing more, nothing less. Just that is the reason for it. Okay, now how to make it is that first use create a array called as f, and let this be equal to np.zeros, meaning numpy.zeros. What this function does is that it creates a numpy array of length n plus 1. So suppose if we say 12, it'll create a numpy array of 13 entries, and all these entries are filled with zeros. Now to go with the question flow of the question, I set this to be int 8. Okay, so integer, so the all the entries here are said to be integers of kind type 8. Okay, and now don't worry about this for now. Let me just comment this up, and okay, let me work with this part of the problem here. Now I set f of 1 to be 1. Here I set f to be 0 throughout the code, throughout the I'm just setting all the entries of f to be 0, and I'm just setting the first entry to be 1, and that's it, by manual adjustment. Now what I'm doing is that I'm using this for loop, and I'm using this Fibonacci formula over here, formula to here, just explicitly, but I'm calculating the Fibonacci numbers. Okay, now if I were to run this, I don't have to copy, since it's a full script, I don't have to select all this and right click and say run selection or current line. I don't have to do all this. Since this is a full-fledged code with no extra inputs and all, just press this option button over here, run a file or F5 button. So press this, all the numbers you enter over here, they come up, all this entire function gets executed, program gets executed, and they come over here. Now the program is waiting over here. So if you just enter like 12 entries, press enter. Okay, all this iteration gets done over here, and the Fibonacci numbers up to 12 terms and it's being printed over here. Now the catch here is that when I use int 8, I get the last entry to be minus 112. Now that's a little funny. Like, Fibonacci series means the sum addition of the previous two entries. Now, so because of that, this entry will be 89 plus 54, which is 144. If 144, okay, but this is turning out to be minus 112. Now, why is that? Now, one way to look at the reason to understand what's going on here is that you need to understand what exactly is happening at the storage level. For which, let me explain you guys that. Okay, let me just open a new file, a new template, writing template, nothing big. Okay, I have my tool over here. Okay, let me just explain you guys. Okay, we saw that we are using int 8. Okay, now this size is too big. So let me set this to be 10. Okay, what we're using is that we're using int 8 over here. Okay, so it means you're using integers which take 8 bits of memory. So in your computer, in the memory, you have 1 2 3 4 5 6 7 8 entries, 8 bits to store a value. Okay, for integers, how it is stored is that this entry is used for storing the sign. Okay, the common notation is that 0 is for positive values, and then 1 is for negative values, and then that's how the first bit goes by, and this is actually the most significant bit, and this is your least significant bit, or sometimes they call it leftmost bit, and this they call it rightmost bit. Okay, now if that being said, okay, where all the remaining entries over here, okay, excuse me for my poor drawing skills, all these are used for storing your numbers. Since all your integers get stored in the form of binary values here, okay, you will have 7 locations to store zeros and ones. So ultimately, if you look at the sign convention, everything, you can store between minus 2 power n minus 1 to 2 power n minus 1 values, where n equals number of bits. So for this, we'll be in a position to store minus 2 power 7 to 2 power 7 minus 1, meaning if you just translate this to actual numbers, you'll be in a position to store up to from minus 128 to 127. Okay, you'll be in a position to store up to minus 128 to minus 128 to minus 127. Okay, now what happens in this example? What happens in this example is that when you add these two, uh, the maximum possible 127. Okay, let me write it over here. 127 in binary decimal is actually 0 followed by 1, 2, 3, 4, 5, 6, 7 values, 7 ones continuous. That is how your 127 is stored in binary in your system. Now whenever you come across 128, what will happen is that the entire thing is reset and one value gets added to here. You get a carryover and one gets added to here. So what happens is that your sign trips. So what you'll have is that when you have 128, this will be 0 over here. This 0 over here becomes 1, and the entire thing becomes 0. Like that. So like that, but that we're not adding 8 here, we're adding more than that. So we're getting like 144. So you get a negative minus 112, something of that sort. Okay. Now, if you guys want a funny example as where this kind of a problem happened, remember about a person called as Psy in his Gangnam Style video. Okay, it seems that video got viewed so many times in YouTube that at one point of that the number crossed beyond a particular value, and the number of views becomes negative. And then YouTube had to go to the video, find the video, and set the variable allocated for storing the views to be. It just had to reset the value so that it accommodates more views and all, more numbers and all. It's actually a number overflow. This is what happened. This is what is happening over here. Now, this kind of thing can quite happen often in your commands and programs. So one remedy to that is that set this to be int16. Now when you run the same, so I give 12 terms over here. Now this is fine, but still even int16 has its own limitation. I mean, after a particular value of integers and stuff, this again number will you'll get a negative value indicating that after some time you'll get a negative value indicating that the number has overflown. So this kind of thing can happen once in a while, so be careful about that. Okay, and this is a kind of a traditional way of writing stuff. Okay, what can be done is that instead I have an alternate way. Okay, this may not be an efficient way, but it's an interesting way to look at. Okay, now let me comment this out. I introduce two variables, a to be 0 and b to be 1, and I run this particular expression over here. What this does is that okay, let me if I can zoom it up. Yeah, I can zoom it up over here. Now what this does is that now a is set to be 0 and b is set to be 1, and this expression a comma b equals b comma a plus b, what it does is that it takes the initial value of a and b. Okay, what it actually means is that it takes this part, takes the actual value of a and b and gives it some temporary variable. Let's say this temporary variable to be t. It calculates t equals a plus b, t1. Let this be t2, and then let another variable t1 be t1, and let this value be b. Okay, so it takes some temporary variables inside for this execution, t1 to be b, t1 and t2, like that, and then the value of b is kept assigned to t, and value of a plus b is assigned to t2. That's in the first step. In the second step, what will happen is that a, this looks like a d, A will be equal to T1. Okay, B will be equal, oh, come on, okay, that looks like a B. B will be equal to T2. B will be equal to T2. Okay, now after this, T1 and T2 are scored off, are deleted. Now this is exactly what happens over here. This is actually some kind of a swap and unpacking mechanism, and when this is done, the value of A gets stored to the value, the ith entry of Fibonacci of this matrix. Okay, entails Fibonacci matrix, and then everything else is same. This is actually another Pythonic way of doing this entire option, of this entire thing. Okay, you can do this with just with plain list and plain tuples and everything. It's possible, and they have other options like using recursive operations and everything. When I done this when I did this workshop in my department, the students came up with different approaches. Like one came up with defined a function and came up with a function which has recursion built into it. Some person just gave a just a recursion, just a simple looping statement which does not need any array, but just takes the input value, calculates it, and just prints on the run without storing anything like that. Have multiple options. I'm just saying that this is one of the ways to do it. It's not the best way, it's not the best way, I'm just saying, but it's one of the way. But this helps to give you guys an understanding of what happens to memory overflow, and a swap and unpack mechanism, and how to use numpy arrays. Just an idea of how to use numpy arrays. Okay, that's all I have for you guys in this tutorial. And okay, since this sheet might be helpful for you guys, so what I do is that let me just export this image. Let me just export this image. I don't want this. Let me export this as a JPEG. Let me put this as ex1. Number of resolutions, I don't care, it's like fine. Oh well, that's funny. Okay, export this as no camera. Okay, I think I have to save this file first. Sample1.kra. Fine. Now let me export this file. Export this, and let me export this as PNG image. I think that will be sufficient. ex1 .png. Then I save this. Nothing much. I'll just click OK. You'll have the picture ready. I'll put the picture ready. I'll put the picture here. That's all I have for you guys in this tutorial. In the next tutorial, we look at the problem 2, which is a little more complicated. We look at that, and after that, we will start working with the file extraction and everything. Now, thank you guys for watching, and I'll see you guys in the next tutorial. So, take care.